Surgeons these days utilize the CT scan technology in order to scan the human body to perform surgeries or other purposes. On the other hand, more than 200,000 people are diagnosed by primary brain tumor each year. This information was taken from Kota Jakarta. And one of the casualties is my friend. He was diagnosed by primary brain tumor. And he was treated in a local hospital. And of course, several treatments were given to him. But as time goes by, there is no significant difference in the progress of his health. So he was then taken to an international hospital. But sadly, after several treatments done there, he passed away. And of course, his relatives are mad enough, and they go to doctors and ask, how can this happen? The international hospitals concluded that several mistakes were made by the local hospital, especially in the surgical procedure. So we concluded that, of course, the local hospital lacks education. I mean, not lacks education literally, but lacks of information of how to deal with such conditions. So in this research, I hope that we can connect both terms, watershed and CT scan, so that we can make a high contrast image that is very useful to doctors, especially surgeons, to locate brain tumors inside the human body. My name is Harman Dewantoro from Citati Christian Senior High. This is my research about watershed method used for CT scan imaging. Hope I didn't bore you. Okay, I believe that you all are already familiar enough with the term CT scan. But what I worry is that you guys are not familiar enough with the term watershed. So let us begin our brief explanation. CT scan is basically a machine, a tube-like machine. It is used to scan inside the human body to find abnormalities such as tumors or cracked bones, usually. But I encounter several problems, including the images that are expressed in graph image that are created by CT scans. This is caused by close catchment patients that are very hard to differentiate. This causes color difference that is undefined. So before coming to the watershed, I want to explain about my base concept how to solve this problem. As you can see in the gradient on my right side, factor n is projected through a line ax plus by plus c equals to 0. And on my left side screen, as you can see that the factor p, the projection of factor p from q is factor p1, as you can see in the equation on the left side. So that we can combine this concept to form this equation. Actually, this equation already exists in the 19th century. So the name for this equation is orthogonal projection formula. As you can see, it is basically a perpendicular prediction or perpendicular projection to a line, which will then we use algorithm to further analyze the numbers. Okay, let's discuss about watershed. It is basically a method for filtering image. It is used mostly in computer stuff. And of course, watershed method eliminates double catchment basis, which we do not want to be in our image. Watershed consists of two types of segmentation. First is the full segmentation and partial segmentation. Full segmentation involves taking away the object from the background by finding the threshold. And partial segmentation means moving the threshold up and down so it can move from segment to segment. This is created by the full segmentation. If you do not know what watershed looks like, this is the final form of watershed. It is simple enough. It gives us an outline so that we can find the apex of any 3D spectrum. So let us come to our methodology. It consists of two parts, pre-processing and processing. Pre-processing involves applying the orthogonal projection formula to classes of the corresponding gradients. We will discuss about this more later on. And then we come to the processing part, which is the watershed itself. Watershed consists of flooding. flooding means turning a 2D scheme into a 3-dimensional scheme by changing this 2D scheme into a grayscale. As you can see, the lower part of the 3D scheme is both catchment basins. As you can see, the darker colors are expressed lower in the 3D schemes, and lighter colors, such as white, are expressed higher region in the 3D scheme. This is the steps of flooding. Those are the two closed catchment basins. Then we flood the basins, but the center fuses. So what we want to do is to eliminate the fusing so that we put a dam in the middle. This dam will form a gradient that can be computed digitally. To give you more simple illustration about watershed, you can see in this cone, this is the higher region of the image, and this is darker regions of the image. So that this part was flooded as it is being turned into the scheme. The middle cone is submerged by the flooding. So in order to prevent the both catchment basins to fuse, we need to build a dam so that we have an outline in the center to represent the apex of the middle cone. Then we apply again the orthogonal projection formula to the clusters of corresponding gradients. To give you further explanation about the orthogonal projection formula, you can see in this image, for example, if I take three corresponding lines, three corresponding gradients, and they intersect each other, of course. And if you take one line and apply the orthogonal projection formula in every cycle, you can find the limit cycle. You can shift the projections through the line 1 so that we can have different results. But of course, what we want is a limit cycle. So the results can be shown by showing you this image. This is the image after the orthogonal processing. As you can see, it is more detailed compared to the raw watershed. So we can finally come to the conclusion that watershed can provide accurate gradient to act as an outline for surgeons. And moving the threshold up and down, we can move and differentiate the 3D schemes of each layer. Also, simplification of raw watershed image can be done using orthogonal processing. Thank you for listening, and have a nice day.